Alright, so in this video we'll be solving quadratic equations. There's going to be 5 practice questions, all in increasing difficulty. And so let's just go ahead and I'll give you some time to pause this video and solve this first one, and then we'll go over it together. Alright, so for this first one, it's a factorable equation. So which means that we're basically looking for two numbers that multiply to this value and add to this value. So in this case, we want two numbers that multiply to 4 and add to -5. Notice that when you have -1 times -1, -4 times -1, that gives you 4. And when you have -4 plus -1, that just subtracts, gives you -5. Perfect. So basically the procedure is you would write this middle number as a sum or a difference of these two numbers. So what I mean by that is I'll just go ahead and not these two numbers, I meant these two numbers. So basically it's going to be -4x minus 1x, because there's -1 there, plus 4 equals 0. Actually, just for the sake of ease, I'm just gonna, doesn't really matter which order you write it in, just easier. From here, you basically factor by grouping. So you're basically looking at these two as if they're like separate equations. And so for the first one, I can factor out x, which gives me x minus 1. And for the second part, I can factor out -4. 4x minus 1 equals 0. And now we can factor out x minus 1. And we're left with x minus 4 is equal to 0. Now at this point, you have to recall one property, and that's known as the zero product property. So if you have two numbers, a times b, and if that's equal to 0, then that means a and b is equal to 0. Alright, so knowing that, we can basically split this into like two different cases. So we know that x minus 1 is going to be equal to 0, and x minus 4 is going to be equal to 0. Solving each of the equations, we get x is equal to 1, x is equal to 4, and we get that x is equal to 1 and 4. And that would be your solution for this question. Alright, so here's the second problem. Go ahead, pause the video, and try it yourself first. Alright, so for every quadratic equation, you basically want your right side to be 0. Okay, and the reason for that is if you look at our question before, we used our zero product property, and that's basically what you're trying to do every single time, because solving a quadratic by factoring is basically the easiest method. Well, actually solving a trinomial. So we want the right side to be 0, so basically we'll just subtract both sides by 10. So we get x squared plus 2x minus 18 is equal to 0. Now what you'll notice about this is it's not factorable, which means that we need to resort to either completing the square or the quadratic formula. Now in this video, I'm not going to be completing the square because I already have another video, you can go check it out if you want, where I basically just derived the quadratic formula through completing the square. So we'll be using quadratic formula, and if you recall, that is x equals -b plus minus square root of b squared minus 4ac all over 2a. For a quadratic of the form ax squared plus bx plus c is equal to 0. Alright, so we just plug in our values, -b, which is going to be -2, plus minus square root of b squared, which is just 2 squared, 4, minus 4 times 1 times -18, all over 2 times 1. So now we just basically simplify this radical here at the top. It's going to be 4 minus 4 times 1 times -18 is -72 all over 2. And then we just keep simplifying. Plus minus 4, it's going to be 76, root 76 over 2. You got to notice root 76 is actually simplifiable because it could be written as 19 times 4. So it's going to be x is equal to -2 plus minus 2 root 19 all over 2. And we can just basically just divide both by 2. And so we get negative 1 plus minus root 19. And that is your full solution. Alright, so this is the third problem. Go ahead, try for yourself. Now if you've tried the problem yourself, just like all the other quadratics, we want the right side to be 0, therefore we just subtract both sides by 7. And so we get minus 12 is equal to 0. Now, immediately what you notice is, first of all, it's not factorable. Another thing is that we have a leading coefficient of x. It's a little different. But again, it's not factorable, therefore we'll just be using the quadratic formula. X is equal to negative b plus minus square root of b squared minus 4ac over 2a. And so, just plugging in our values, we get 3 plus minus square root of negative 3 squared, which is just 9, minus 4 times 2 times negative 12. All over 2 times 2, which is just 4. And here, we just gotta simplify the radical, which is gonna be 9 minus 4 times 2 times negative 12, which is negative 96, all over 4. 3 plus minus, that's gonna be 105 over 4. And I'm pretty sure square root of 105 is not able to be simplified further. So there you go. That'll be your full solution. So yeah, we had the leading coefficient of x. In this case, it really didn't make the question any much harder. Alright, so here is the fourth question. If you hear some like background noise, I'm sorry. That's like my bowler going off. Anyways, just like all the other questions, we want the right side to be 0. So we do this, and we in this case add both sides by 7. And so we get plus 2 is equal to 0. Again, it is not factorable. Therefore, we just use the quadratic formula. I'm not even going to recite the quadratic formula. I've done that for the past 2 questions. So it's just going to be negative b plus minus square root of 4 squared, which is 16, minus 4 times a times c, all over 2 times 3, which is 6. Alright, so now we just go ahead and simplify all of this. So 4 times 3 times 2 is just going to be 24 over 6. Now, what you'll actually notice here is you get a negative number inside the square root. Therefore, we have a complex solution. So just recall that square root of negative 1 is equal to I. And so that's how we're going to simplify this radical right here. So we have x is equal to negative 4 plus minus. We can rewrite this as 8 times negative 1. And what is square root of negative 1? That is just I. So we can write that as square root of 8i over 6. And we know that root 8 is simplifiable to 2 root 2. So we get plus minus 2 root 2 I over 6. And we can just divide it by 6. So we get 3 plus minus root 2 I over 2. Wait, no, I meant 2 over 3. There we go. And that would be your full solution. Alright, so here is the fifth or the last question. I marked it as challenge because it's the most challenging one on this list. So here, go ahead, take your time, try for yourself first, and come back and we'll go over together. Alright, so for this question, I'll tell you right now, I'm not even here at this point. I'm not even thinking about solving it through factoring. Too much going on. So we're trying to use the quadratic formula here, but recall that quadratic formula is only applicable to quadratics of the form ax squared plus bx plus c is equal to 0. And here, it's not really in that form. There's actually 5 terms to this. 1, 2, 3, 4, 5. So you just gotta notice we're looking for each individual a, b, and c value. So what is a? It is coefficient in front of x squared, right? Which in this case is just 3. Now the problem comes when we're trying to look for b. It's the coefficient of just x. which we have two different. We have 4 and negative 2 root 5. So something we can do here to actually just make it one thing, we can just factor out x. So if we factor out x from 4x and negative 2 root 5, we get 4 minus 2 root 5 of x. And we just leave this stuff. And bang, there we have it. This whole thing is our b value. And now what is c? C is just the numbers that are not coefficients of any type of x. We call that the constant term. We have actually two numbers that are constant. And yeah, the whole thing is just our c value. You could technically just put it as a decimal, but here we're just trying not to use a calculator. And so we just leave it as that. And now we established that a is 3. Our b is 4 minus 2 root 5. And our c is 1 minus root 5. And so we can just plug this into the quadratic formula. So we get negative b, which is negative 4 plus 2 root 5, plus minus b squared, which is here just 4 minus 2 root 5 squared. And it's going to be minus 4ac, 4 times 3. I'm going to put it in bracket. 4 times 3 times 1 minus root 5. It's all over 2 times a, 2 times 3, which is just 6. Alright, and now this is basically the hardest part of the entire question. It's just simplifying this. First we need to simplify, that's an ugly square root. First we need to simplify this little part right here. And we can actually do that pretty easily. Because recall that a minus b, whole thing squared, is equal to a squared minus 2ab plus b squared. So if you're like learning factoring from day school, it's probably one of the first things you'll learn is this like perfect square trinomial patterns. So we can actually just use this formula, you could say. It's really easy to derive, but yeah, we can basically just use this to easily simplify this first part here. So here a is basically 4, so we get 16, and it's gonna be 4 times 2 root 5 times 2, which is minus 16 root 5, and it's gonna be 2 root 5 all squared, giving you 20. And now we have that minus this thing, which is going to be 4 times 3 is 12 times 1 minus root 5. And I'll just simplify. You can just distribute the 12. So you get 12 minus 12 root 5. Root 5. All right, and it's still all over 6. So we just keep all of these stuff here to the left. And now we can start subtracting. Well, actually, first we gotta distribute the negative sign. All right, so it's gonna be negative 16 minus 16 root 5. Well, actually, I'll add the 16 and 20 right now. So you're supposed to get 36 minus 16 root 5 because you just added the constants. And it's gonna be minus 12 plus 12 root 5 because you distributed the negative sign. It's still all over 6. X is equal to negative 4 plus 2 root 5 plus minus square root, oh my god, square root 36 minus 12, which is just 24. And then we have negative 16 root 5 plus 12 root 5, which is just minus 4 root 5, all over 6. And so what you'll notice between these two numbers, you can actually factor out 4. So we just gotta write all of this stuff. And we can factor out 4. So it's basically gonna look like 4. Factor out 4 from 24, you get 6, and it's gonna be minus just root 5. And 4 is a perfect square, so we can actually just pull that out of the square root. Get plus minus 2 all over 6 minus root 5. Still all over 6. And then we can just divide all of it by 6 because that's our denominator. So we'll be getting 2 plus root 5 plus minus just the square root, 6 minus root 5 all over 3. And that will be your full solution to this equation right here. Alright, so that'll be it for this video. Hopefully this video helped reinforce your understanding of quadratic equations, how to solve them, maybe reminded you of what the quadratic formula is, the zero product property, how to factor, all those good things. So that'll be it. And thank you. And I'll see you in the next one.